All right, hi guys. How we doing? We're gonna do review for Unit 6, this periodic table. I'm only gonna do uh the multiple choice. The short response, I'm just gonna like post the answers, but I'm not gonna make a video about it. It's only 7 questions, and if you guys have questions about it, y'all can just ask me in class. But anyways, let's get started. So number one, which group 15 element is classified as a metal? So I'm just gonna go over to my reference table. um, Feeling pink for this video. So we're going to group 15. And again, they're asking which one is classified as a metal. So there's lots of different stuff going on in group 15. We've got nonmetals, we've got metalloids, and we've also got metals. So you really do need to know which ones are the metalloids. Again, there are 8 of them. We've got boron, we've got silicon, germanium and arsenic, antimony and tellurium, and polonium and acetine. So there are 8 in total. So you need to know what they are. Now, this is the best way to really memorize what types of elements are what. Because if you remember these 8, this is like the border, basically. Everything this way, those are all the metals. Everything this way, that was supposed to be an arrow, but it didn't come out looking like one. Give me one sec. Marker. Everything that way is non-metal, again, aside from hydrogen, which is over here by itself. So now that I've kind of like drawn everything right here, okay, I know that these 2 things here, nitrogen, phosphorus, this is to the right of the staircase. So these are non-metals, so this does not count. Arsenic and antimony, those also don't count. These are metalloids. That's not what we're asking for. So these don't count either. Bismuth is the only thing on this list here that is a metal. Okay, so we want to go with bismuth. Let's go back over here. Let me get rid of all this nonsense. Okay, so we want to go with bismuth. Nah, I don't like that. Pink. Okay, next one. Number 2, elements on the periodic table of the elements are arranged in order of increasing. This is just a memorization thing. Atomic number. This was figured out by Henry Moseley. Okay, first was Mendeleev. He came up with the periodic table. He organized it, but he organized it a little wrong. He organized it according to atomic mass. But if you actually look on the periodic table, for example, let me zoom in. Okay, so like right here, this is the perfect thing to take a look at right here between cobalt and nickel. If it was by increasing mass, then this wouldn't make sense because this is 58.9, this is 58.6. So you're going down. But if you look, atomic numbers continuously go up as you go from left to right. So we do this by atomic number. Please make sure that you know this. They love to ask this every single year on the Regent. Number 3, which sequence of atomic numbers represents elements which have similar chemical properties? So things that have similar chemical properties will be in the same group. So you want to look for the things that are describing something in the same group. Now it is going to be D. If you look on your periodic table, elements 4, 20, 30, and 88, these are all in group 2. These are all alkaline earth metals. All right. All right. Number 4. The element in period 2 with the largest atomic radius is, so let's go over to period 2. All right, so period 2 is lithium. We got lithium, beryllium, we've got boron, carbon, nitrogen, oxygen, fluorine, and neon. Again, they're asking for the one with the largest atomic radius. Now, again, the general trend is that as we go across a period, things get smaller, except for when you hit the noble gases. Now, the noble gases are always slightly bigger than the things before them, but typically the largest thing in each period is going to be the first thing that you see over here. Okay, so the thing that's going to be biggest in period 2 is lithium, and group 1, these are the alkali metals. So we are going to want to go with choice C, alkali metal. Number 5, which period of the periodic table contains more metallic elements than non-metallic elements? I've seen this question quite a few times. Now this one is, you can go through each one, but the thing that you want to keep in mind is that period 4, This is where you first start to see the transition metals. Okay, transition metals don't exist in period 2 or period 3, but they do exist in period 4. And this makes up the bulk and the majority of the period. So all of these things are metals. Okay, these are metalloids, these right here. And then these are the nonmetals. So this is the one period where majority of the things are metallic rather than non-metallic. So we're going to want to go with, let's see, we're going to want to go with choice D, period 4. Number 6, what is a property of most metals? All right, so A, they tend to gain electrons. No, that's describing nonmetals. They tend to lose electrons easily when bonding. That's the one that we want to go with. Metals love to get rid of their electrons so that their last shell can be filled. They're poor conductors of heat. That's not true. They're great conductors of heat, and they're also great conductors of electricity. So C and D do not make any sense. So you definitely want to go with choice B. Alrighty. Number 7. Which statement describes a chemical property of iron? All right. So A, iron can be flattened into sheets. That's not it. That's a physical property. This is also talking about, this is malleability. Okay. Iron conducts electricity and heat. This is conductivity. That's also a physical property. Iron combines with oxygen to form a new product. This is a chemical property. D, iron can be drawn into wire. Again, that's another physical property. Being drawn into wire is also called ductility. Okay, so you want to go with choice C. Number 8, which element is malleable and can conduct electricity in the solid phase? So if something is malleable, they're most likely talking about a metal. So you want to go with the thing that is a metal. Iodine is a nonmetal. Sulfur, nonmetal. Phosphorus, nonmetal. Tin, or Sn, is the only thing here that is a metal. So it's the only thing that will be malleable. Number 9, an element that is malleable and a good conductor of heat and electricity. So they're talking about a metal again. And they're saying what would its atomic number be like. So they're literally giving you different elements without telling you what the element is, but they're giving you the atomic number, which is basically the identifier. So any element with atomic number 16 is sulfur. 18, that's argon. 29, that's copper. And 35 is bromine. Now, again, we're looking for the metal. Sulfur, argon, and bromine, those are all nonmetals. Copper is the only thing that is a metal here. So you want to go with copper, choice C. Number 10 and 11, which element is a liquid at STP and has low electrical conductivity? So remember, there are 2 things on the entire periodic table that are liquids at STP. That is bromine and that is mercury, Hg. Now, they're looking for the thing that has low electrical conductivity. So it's not, so how do you know which one it is, right? Because they're both liquids at STP. How do we determine which one? Well, we know it's definitely not these 2, but mercury, even though it's a liquid, it is still a metal. So it has high electrical conductivity. So it's not going to be this one. Bromine is a liquid at STP, and it is also a nonmetal. Nonmetals have very low electrical conductivity. So you're going to want to go with bromine. All right, number 11, which characteristic describes most nonmetals in the solid phase? Now, nonmetals are basically the exact opposite of metals. They are not malleable. They're not flexible. You can't hammer them into sheets. So you can get rid of A and B. They're not malleable. They are brittle. Some of the solids are brittle, right? Carbon, sulfur, so on. They are brittle, but because they're non-metals, they do not have luster. They don't shine. So they lack luster. So we're going to want to go with choice D. Choice C doesn't make sense. They do not shine. Alrighty. Oops, next page already. All right, number 12. Properties of nonmetals include, now, again, something to memorize about nonmetals is that I'm going to write this down, they love electrons. Okay, and this is the thing that you really want to keep in mind when you think about nonmetals versus metals and how it relates to the periodic trends. Now, again, ionization energy, this is the energy needed to remove electrons, and electronegativity, En, is attraction for electrons. So think about the properties of nonmetals. Nonmetals love electrons. So to remove an electron from something that wants more electrons is very difficult. So they tend to have very high ionization energies. So I know that it's not A, it's not B. Since they love electrons, this goes hand in hand with this. They have a very, very high attraction for electrons. Again, the nonmetals are to the right. They're very close to the configurations of the noble gases. So they need to usually just gain a few electrons in order to be stable. So they have high ionization energy and also high electronegativity. So we're going to want to go with choice D. Number 13. So we have this table shows properties of elements A, B, C, and D. And they're asking us which element is most likely a nonmetal. So we can use the information that we just looked at in number 12, actually. So we know that nonmetals have high electronegativities and high ionization energies. So I know I can eliminate A and B. So now it's between C and D. So we got element C, high ionization energy, high electronegativity, but low conductivity of heat and electricity. This is something that is in line with the properties of nonmetals. Nonmetals are not good conductors of heat or electricity, so we're going to want to go with choice C. Again, nonmetals do not have high conductivity of heat or electricity. They're very poor conductors. Alrighty. Mouse. All right. Next one, which element is a noble gas? Again, just go to your periodic table right over here. Anything in group 18 is a noble gas. And so this one is just going to be Kr or krypton. Okay. Antimony is not a noble gas. It is a metalloid. Gold and francium are both metals. Number 15, which of the following gases is monatomic at STP? Now, again, when you come to a word in chemistry and you don't know what it means, use your knowledge of the language. Mon is like mono. That means one. Atomic is atom. So they're saying which one of these exists as just one atom. Okay. Now, this is where you have to remember our beautiful acronym, Honkelbrief. Okay. Honkelbrief is the acronym that describes and tells us all the things that are diatomic. These are the things that exist like this. So for example, hydrogen is always like this. Hydrogen you never find hydrogen just floating around in nature as just like one atom like this. It's always bonded to another hydrogen. Same for oxygen. So it's not hydrogen, it's not oxygen. Oxygen is always like this right here, HO. And chlorine. Chlorine's right here in Honkelbrief, Cl2. Okay, so all of these exist as diatomics. Helium is the only one that is monatomic. Again, helium is a noble gas. Noble gases like to bond to what? To nothing. So I don't know why I put a question mark there. I think because I was asking a question while I was talking. But anyways, noble gases don't want to bond with anything at all. They don't even want to bond with each other, right? They already have perfect valence shells. The only reason that you bond with something is to either gain or lose electrons so you can satisfy your octet. Noble gases are already satisfied with their valence electrons, so they don't need anything else. You never find them bonded to anything, or at least normally you don't. So we want to go with helium. All right, 16. An atom of argon in the ground state tends not to bond with an atom of a different element because the argon atom has, we literally just went over this, a total of 8 valence electrons. Again, the configuration for argon is 288. This is element 18. And we can see that it has its octet. So it is stable the way it is. This is why it doesn't bond with anything. All right, number 17. Which element is not a metalloid? Again, this is just a matter of knowing which ones are a metalloid. And I know that my metalloids are boron. Looking at my periodic table, we've also got silicon, we've got germanium, arsenic, we've got antimony, tellurium, polonium, and astatine. So you got to look for the thing that's not on this list. The only thing that's not on this list is sulfur. Sulfur is a non-metal, so it's not a metalloid. Number 18, the element arsenic, which is right here in this list of ours, has the properties of, okay, all of these things are metalloids. Metalloids have properties of both metals and non-metals. So we're gonna want to go with the choice C. Number 19, same sort of question. Which element exhibits both metallic and non-metallic properties? Look for the metalloid, and this one would be Let's see what it is. This is Te, tellurium. Alrighty. It takes so long to erase. Okie dokie. Moving on to the next page. Number 20. All right. So number 20, which element is a liquid at room temperature? We already touched upon this. Okay. Now again, there's only two options. It's, one second, let me get the pen. It's either bromine or it's mercury, Hg. And we don't see bromine here. So our only other option is mercury, Hg. The only metal on the table that is liquid at room temperature. All right, which, number 21, which substance exists as a metallic solid? So they're literally asking which one is the metal. Argon, noble gas. Silicon oxide, there's no metals here, not a metal. Carbon dioxide, not a metal. The only thing that's a metal here is Au. This is gold. 22, all isotopes of which element in group 16 are naturally radioactive? So this is kind of going actually back to, this is actually going back to unit 5, which is nuclear chem. But also asking properties of elements in general. So still has to do with unit 6 as well. So they're saying group 16, which one is naturally radioactive? So I'm looking at group 16. I'm looking at the atomic numbers 8, 16, 34, 52, 84. Aha, there we go. If you reach back into the depths of your brain, okay, we spoke about elements 84 and above. Elements number with atomic number 84 or above have no known stable isotopes. So they're all radioactive. So let me just get rid of this. So we're going to want to go with PO, polonium. This is atomic number 84. Number 23, at STP, which element is a solid? Again, you have to just memorize what things are solids, liquids, and gases, okay? The easy thing is the metals. All the metals are solid except for mercury. Now the non-metals is what can be a little bit complicated. So here's the slides. So this is just something that I would commit to memory, okay? So the only solids are going to be sulfur, iodine, phosphorus, carbon, and selenium. These are brittle solids at room temperature or STP, okay? Where did this go? All right, so again, which element is a solid at STP? Not hydrogen, that's a gas. Nitrogen is also a gas. Argon, also a gas. Carbon is one of our brittle solids, okay? All right, number 24. What is the total number of valence electrons in an atom of phosphorus in the ground state? So this is also being able to use the periodic table, but also goes back to unit 4. So phosphorus is 285. But we've been talking about valence electrons throughout the whole unit. Valence electrons are right here in the very last shell. So it's got 5 in the ground state. All right, number 25, 26, 27. All right, 25. Which electron shell contains valence electrons of a radium atom in the ground state? So radium is element Ra. That is right here. Okay, Ra is in period 7. So again, radium, that's Ra. It's in period 7. That means that it's got 7 rings, 4, 5, 6, 7. Pretend that that's 7. So its valence electrons are always in the last one. This doesn't make sense. We don't have 18 shells. The max you can have is 7. So it's in the 7th shell because it's in period 7. Number 26, which sequence of elements is arranged in order of decreasing atomic radii? So they're asking where is it getting smaller, okay? So let's look at choice 1. Give me one sec. Let me get rid of all this stuff. All right, so in choice A, we're looking at these 3 right here: aluminum, silicon, and phosphorus. And they're saying, again, which sequence of elements is arranged in order of decreasing atomic radii? And this is perfect because as you go this way, okay, aluminum is the biggest here. And then as you go this way, again, because there's more protons, there's more nuclear pull. It's pulling those electrons in silicon and phosphorus closer to the nucleus. So we're getting smaller as we go from left to right, from aluminum to silicon to phosphorus. So we got lucky because it's just choice A. But if it wasn't, you just have to keep going through all of the choices. Number 27, which of the following atoms has the largest atomic radius? So again, let's go back to our periodic table. So they're giving us these options for us to look at. They want us to look at and compare sodium, potassium, magnesium, and calcium. So that's this little group right here. Okay, and they're asking which one is the largest. Now, the ones that we can knock off right off the bat are sodium and magnesium. They're in period 3, meaning that they have 3 shells. Potassium and calcium, they're in period 4. They have 4 shells, so naturally they're bigger. Okay, now it's really then between potassium and calcium. But remember, as you move this way, okay, there's more protons. So the more protons you have, the more nuclear pull there is. So calcium, because it has more protons, its nucleus actually pulls on its electrons and brings those electrons in closer to it. So calcium is actually smaller, meaning that potassium is going to be the biggest option here. And if you don't remember these trends, again, it's your last resort, but if you need the crutch, use your reference table, go to table S, look at the actual sizes of these things and compare them. Okay, but again, last option. So again, this would be choice B, potassium. All right. Question 28. Oh, yeah. Okay. Which atoms have a larger atomic radius than atoms of silicon? So let's go back here. Let me just move this over for a sec. Dope. So the thing that we're focusing on is silicon. And what we're comparing to it, I'll do a different color. We are comparing sulfur. We're comparing carbon. And we are comparing chlorine. Okay. Oh, wait. Am I thinking the right thing? And we're also comparing sodium. My bad. I knew I was missing something. Okay. So we're comparing these 4 atoms to silicon, and we want to know which one is bigger than silicon. Okay. Now, the thing here is that carbon, we can automatically eliminate. Carbon only has 2 rings. Okay. Silicon and everything else that is circled, sodium, sulfur, chlorine, they all have 3. So we at least want to be in the same period. Now, all these things have 3 rings, but some of the rings are closer to the center. Again, as you go this way, there's more nuclear pull. So as you move from left to right, these things are getting smaller. Okay, so sulfur and chlorine are even smaller than silicon because they have more protons in their nucleus, meaning that the nuclear pull is tugging on those electrons more strongly and pulling them closer to the center. Sodium, on the other hand, for one, it's a metal, and it doesn't have nearly as many protons as these guys over here. So there's not that much nuclear pull. So sodium is going to be the largest one. Again, in any period that you're looking at, the one that the atom that's going to be the biggest is going to be in group 1. It's going to be one of the alkali metals. So we're going to want to go with sodium as our option for this one. So we'll just circle that. So we've got sodium. All right. Number 29. Which characteristic both generally decrease when the elements in period 3 on the periodic table are considered in order from left to right? Now, let's just go back real quick. So we want to look for the things that are decreasing. Okay. So kind of just easier to like draw a makeshift. Oops, where did the pen? Easier to just draw like a makeshift periodic table. Okay. Now, let's look at choice A. Non-metallic properties are decreasing as you go this way. That doesn't make sense because as you go from left to right, you're literally going towards the non-metals. So A and B don't make sense. Okay, because when you move from left to right, you're getting closer to the non-metals, you are becoming more non-metallic. So if you're becoming more non-metallic, it means you're becoming less metallic. So it's between C and D. Now let's look at what else decreases when you go from left to right. This one says atomic radius. Does atomic radius decrease when you move this way? Yes, it does. Again, because of nuclear pull. This one wouldn't make sense because ionization energy increases as you move towards the noble gases. Again, it gets harder and harder to remove things, remove electrons from things that want electrons. So that's the nonmetals. So nonmetals love electrons. They don't want to get rid of them. They have very high ionization energies. So this one would be choice C. All right. Down. We are making our way, y'all. All righty. Number 30. Which element forms an ion larger than its atom? So what they're talking about here, this is going to be a nonmetal. Again, nonmetals gain electrons when they form ions. Okay, so something like chlorine. Chlorine becomes Cl minus. It gains an entire electron. If you're holding more things, you get bigger. Okay, so we have to look for the nonmetal. So it's not sodium. Sodium is a metal. When sodium becomes an ion, it becomes a cation. It gets smaller because it loses stuff. Neon doesn't become an ion because it's a noble gas, so it doesn't like to lose electrons or gain them. Barium is also a metal, so it likes to lose rather than gain. Bromine is the only nonmetal here. Bromine is a halogen, so it's in group 17. Okay, so it only needs one more electron in order to be stable. So it gains one to become stable. So if you're gaining something, you got more stuff to hold on to, it's going to be bigger than its parent or neutral atom. So you want to go with bromine. Number 31, an atom with the electron configuration 282 would most likely do what? 282 describes magnesium. Magnesium is a metal. Metals like to lose electrons. When you lose electrons, I'm just going to write all this down. Metals, they lose electrons. Again, electrons are something that are negatively charged. So if you lose something negative, you become more positive. So they form positive ions. These are the cations. So I can eliminate C and D because I see negative ion here. So that doesn't make any sense. Now, again, when you lose something, what happens? So for example, magnesium. Magnesium is an alkaline earth metal. It's going to lose those 2 valence electrons right there so that its configuration will just be 2,8, which is like neon, one of the noble gases. If we do that, okay, we go from magnesium looking like this to magnesium looking like this. It literally loses an entire shell. So it actually gets smaller. So we want to go with choice A, decreases in size as it forms a positive ion. Number 32, when a sodium atom becomes an ion, the size of the atom, we literally just did this, okay? Sodium is just like magnesium. It's also a metal. So it loses, if it's becoming an ion, it's Na to Na plus. It loses 1 electron, loses 1 because it's an alkali metal. Alkali metals like to lose 1, okay? Its configuration is 281 specifically, loses this one, loses a whole shell. So its size decreases, so it's definitely not C or D. And again, it does this by losing an electron. You don't gain stuff and then, get smaller. So this one would be choice B. Let's get rid of some of this stuff so we can move down. Alrighty. Okay. We're on 33. All right. Bear with me 1 second. Sorry, I'm just trying to look at something here. Alrighty. Okay, 33. Which term represents the attraction one atom has for the electrons in a bond with another atom? This is the definition of electronegativity. This is the attraction for electrons. This is electronegativity. 34. Group 17 element with the highest electronegativity is, so group 17, these are the halogens, okay? So you've got fluorine. Let's go over here. You've got fluorine, you've got chlorine, you've got bromine, and you've got iodine. Now, again, something that we actually went over today is that the element on the table with the highest electronegativity is fluorine. So it doesn't even matter what you're comparing it to. If fluorine is on the list, it is the most electronegative thing. Again, they're all halogens and they all want 1 electron, but fluorine wants an electron more than anything else because of that nuclear pull. It's smaller, okay? And also, it experiences less nuclear pull, there's less nuclear charge, less shielding, so on and so forth. Alrighty, let me get rid of this. Okay, 35. Actually, let me move this down so I don't have to shift this page anymore after this. All right. 35. Elements that readily gain electrons tend to have, so what they're describing here, things that readily gain electrons, they're describing nonmetals. Nonmetals usually have very high ionization energy and also very high electronegativity. They both go hand in hand. Again, ionization energy is how much energy you need to remove an electron. It's very hard to remove an electron from something that wants to gain electrons, okay? And also, because they gain electrons, this speaks directly to their attraction for electrons, and that's the electronegativity. That's the attraction to electrons. Number 36. An element with an electronegativity of 3.2 is most likely classified as this is a pretty high electronegativity. Again, the highest one that you can have is 4.0, and that's a nonmetal. So things that have higher electronegativities are usually nonmetals. All right, 37. Which element has the highest first ionization energy? So we're looking, let me erase this. Let's go to our table. Bear with me, sorry. Okie dokes. So they're asking us to compare these. We're looking at question 37. So which element has the highest first ionization energy? So they're asking us to compare, oh, where's the pen? Okay, sodium, calcium, aluminum, and phosphorus. Now, this one is kind of easy because they're giving us 3 metals and then they're giving us a nonmetal. The nonmetals have the highest ionization energies. Again, nonmetals love to gain electrons. So if something likes to gain electrons, it means it's very difficult to take one of their electrons from them. So you're just going to want to go with phosphorus. Phosphorus is the only nonmetal here. All right, number 38. Highest ionization energies in any period are found in group. Again, the things on the table that have the highest ionization energies are the things that absolutely do not want to give up their electrons, and that would be the noble gases in group 18. Number 39. Which atom requires the least energy to form a positive ion? The way to form a positive ion is to lose an electron or remove an electron. So they're really asking about ionization energy here. This is why it's important to know the definition of everything, okay? So they're basically asking you which one has the lowest ionization energy, all right? So let's actually take a look at our periodic table and compare all these things. So again, they're giving us, let's see, Ge, Ca, Ga, and K. And they're asking us which one is the easiest to take an electron away from. Now again, your ionization energy increases as you move this way. So it makes sense that it would decrease as you move this way. So it's going to be right here, potassium. Potassium is going to have the lowest ionization energy. Okay. Again, it has the least nuclear pull. So those electrons in the valence shell are not experiencing that attraction as much as the other elements in period 4. So it's easier to kind of pluck one of its electrons off from its valence shell. So we are going to want to go with pen choice D. Last question, you guys. Number 40. As the first 5 elements in group 15 are considered in order of increasing atomic number, first ionization energy does what? So again, let's go back. So again, they're asking us to compare the elements in group 15, okay, in order of increasing atomic number. So they're asking us, what is the trend going down? Now, what's the trend in ionization energy? So the ionization energy is going to go down. It's going to decrease as we go down the periods because as you go down the periods, there are more shells. Again, this is that shielding effect that we spoke about. Okay. The more rings that there are, like something like this with 2 rings versus something with a ton of rings, okay, these electrons out here are being shielded from the nuclear pull in the center, whereas this second ring is way closer to the nucleus. So it's much more kind of like exposed to that nuclear pull. So we're going to want to go with choice A, decreases. Alrighty, guys. Don't mind me. I actually just would like to see if I have something up here. Nope, never mind. All right. Anyways, guys, again, the short response, there's only 7 questions. I'm gonna post the answers and I'll also talk about them in class. But aside from that, I hope that this video was helpful. And also the great thing about this video is that you can actually use it again. In the next few weeks because we're going to be having our final exams. So make sure that you come back to these videos. I hope to also make some videos for units 1, 2, and 3 because I only started making the videos in unit 4. But anyways, guys, I hope that this was helpful.